The next thing to look at are the requirements for bacterial multiplication. What do bacteria need in order to grow? Bacteria are a lot like us. They need similar things in order to grow. And they are food, moisture, warmth and time. And we'll look at each of those properties individually. Let's have a look at the different types of food. First of all, high-risk food. This is the major source of nutrients for food poisoning bacteria. They're common food vehicles of food poisoning, usually protein, ready to eat, stored under refrigeration, and no further processing is required. So you can eat them as they are. Raw foods, they're a major source of food poison organisms. Other food types include low-risk foods and ready-to-eat raw foods. Low-risk foods include acid foods, foods with a high sugar, salt or fat content, dry products, includes preserved foods not requiring refrigeration, and foods which you can keep at ambient storage or room temperature. And these are classed as foods which will not support the growth of pathogenic microorganisms. Ready-to-eat raw foods, such as fruit and salad vegetables, should be thoroughly washed before consumption to minimize the risk from low-dose pathogens, which we'll look at later on under foodborne diseases. So high-risk foods then will support the growth of pathogenic microorganisms. They will grow on high-risk foods. High-risk foods have certain properties. First of all, they're high in protein. That's the building block of life. We need protein on a daily basis, and it's the same thing for bacteria. They're high in moisture, and no further cooking or processing is required. In other words, ready to eat food. You could eat it as it is without reheating in a microwave or an oven. Please make some notes on this slide because the temperatures here are very important. First of all, this is a germometer. I feel like a thermometer showing what happens to bacteria at certain temperatures. If we start off at the bottom of the thermometer, we've got minus 18 degrees Celsius. This is the maximum temperature of freezers, whether they're commercial or domestic freezers. So it's minus 18 degrees Celsius or lower. And at this temperature, bacteria will remain dormant. You won't kill them by freezing them, but they won't multiply. The next major temperature is your chiller or fridge temperatures, 1 to 4 degrees Celsius. Again, with a couple of exceptions, bacteria will not multiply at these temperatures. They will remain dormant. The next set of temperatures is the temperature danger zone. That's the red area that you can see. That's between 5 and 63 degrees Celsius. This is where bacteria start to multiply, and this is where they cause a problem. So all food must be kept out of the temperature danger zone. If it's hot food, it must be served above 63 degrees Celsius. If it's cold food, it must be served below 5 degrees Celsius. Now at 5 degrees Celsius, bacteria are starting to wake up from their sleep, and they will start to multiply slowly. As the temperature increases, then they will start to rapidly multiply up to the optimum temperature, which is 37 degrees Celsius. At 37 degrees Celsius, which by the way is body heat, bacteria rapidly multiply every 10 to 20 minutes. As the temperature increases any further, between say 50, 52, 55, it gets too hot for the bacteria, so they will start to die off. Most bacteria are killed by 60 to 63 degrees Celsius. But the next important temperature I want you to write down and remember is cooking temperature, which is 75 degrees Celsius. All food must be cooked to core temperature, 75 degrees Celsius, for it to be safe. At that temperature, all bacteria are killed. The only way you can check that food has been heated to 75 degrees Celsius is by using a temperature measuring device. There are two examples shown there. The one on the left is the one that's most commonly used. It has an attachment which you can insert into the food, into the core, into the thickest part of the food, to make sure it has reached 75 degrees Celsius. Beware of the infrared probe, however, because that only registers surface temperature. These are also called thermocouple probes. That's the hard probe thermometer on the left. In other words, it can be calibrated and it is tip sensitive. Okay, so how do we use a temperature probe? First of all, it should be properly calibrated. In other words, the reading on the LCD should be the temperature inside the food product. And we can do this by self-calibration. First of all, you need to check both ends of the scale. In other words, get a glass of water with some ice and cold water, and get some freshly boiled water. Insert the probe into the boiled water, and it should register 100 degrees Celsius plus or minus 1 degree. Insert the probe into the water with the ice, and it should register 0 degrees Celsius plus or minus 1 degree C. If it's out by more than 1 degree C, then the probe is faulty. Also, the probe should be cleaned and disinfected between use. Now, you can do this with probe wipes, or you can use boiled water, for example.